If you're given the graph of a function, there's a lot of information you could read off of that picture. So this is the graph of a function f of x. It's definitely a function because it passes the vertical line test. Every vertical line intersects the graph at most one location. From this picture, I could tell you a bunch of facts. I can tell you the domain of the function. Those are the x values that you're allowed to plug into the function to get out an f of x value. So the domain is the interval from -3 to 5 in this picture. I could tell you the range. The range is the heights that you can get out, the different values of f of x that you could have. So I could get out any number in between the values of -1 and 2. So the range in this function is -1 to 2. I could tell you where the function is increasing, where the function is going up. And the function is going up on the interval from -3 to -2. And it's also going up on the interval from from 0 to 5. Maybe I should be a little bit more precise in what increasing means. So here's the formal definition of what an increasing function is. The function f of x is increasing if f of x1 is less than f of x2 for x1 less than x2. So what this is saying is, if I read the graph from left to right, if I move in the positive x direction, the function gets bigger. So x2 is bigger than x1, so 2 is bigger than 0, for example. So the height of the function is bigger here. I could even tell you where the function is decreasing. Decreasing is the opposite of increasing, so maybe I should say the function f of x is decreasing if f of x1 is bigger than f of x2 for reading left to right. This function is decreasing on the interval from -2, it seems, to 0. I could even locate the zeros of the function. How do you spell zeros? So the zeros of the function are where the graph touches the x-axis. So the zeros are at -1 and +2. Lastly, I could tell you where local minimums are. A local minimum is a place where the graph is lower than its surrounding values. So there's a local minimum at x equals 0, and there's a local maximum at x equals -2. So let me be a little bit more precise about what I mean by this. So a local maximum is a place x where f of x is bigger than f of let's say f of z for values z near x. So what I'm trying to say is this this place on the function is bigger than values of the function nearby. And the word near is intentionally imprecise if you continue on in mathematics. you will make this near concept more exact. But anyway, we have a graph of a function. From that, we could tell its domain range, where it's increasing, where it's going up, where it's decreasing, where it's going down. We could tell its zeros. We can see where it hits the x-axis. We could find positions of local minimums and local maximums. Let's do this one more time. How about let's find information from the graph of, how about f of x is x squared minus x. So we need the graph here. This is the graph of a parabola. If I plug in 0, I get 0. If I plug in 1, I get 0. So the graph is going to look something like this. Now, if I plug in 1/2 here, I will get f of 1/2, which is 1/2 squared minus 1/2, which is 1/4 minus 1/2. And I believe that would be negative, what is this, 1/4, negative 1/4. So, what is the domain of this function? What are the x values I'm allowed to plug in to get out a height f of x? Well, in this case, there are no restrictions on the domain. I could plug in any real number I'd like. So this would be negative infinity to infinity. What is the range? So the range are all the heights I can get out. And I think the smallest value I can get is negative 1/4. So that is the smallest value, and I can get any value from negative 1/4 on. So that's the range. Where is this function increasing? Well, the function is increasing every value past 1/2. So I'm going to say 1/2 to infinity. And where is it decreasing? Well, it's decreasing on values up to 1/2, going down here. Where are there zeros? Well, there are zeros at 0 and 1. That's where I touch the x-axis. Is there a local maximum? No. There's no place that's bigger than its surrounding values. And is there a local minimum? Yes. At x equals 1/2, there's a minimum right here. Okay, wonderful.